to roll. Today, kids, I will be talking to you because I am Mr. Kraus / Mr. Key. I'm going to be talking to you about regression. All the different kinds. And there's not that many that they're actually going to ask during the trig exam about regression. But we'll talk about a little bit of regression, correlation, coefficients, and all that old stuff too. So, let's just get going. Let's just do it. What does this mean? Correlation coefficient. Correlation coefficient, as far as this goes, it's a linear correlation coefficient and what we're talking about with this data. And what we want to find out is how it basically gives you a number between 0 and 1 that tells you how, what's the word I'm looking for? Consistent. Let's do it consistent the data is. How much can you rely on this data? So example, if I was to draw on this line of best fit, notice the line has a positive slope. If I draw that line of best fit and it looks something like that, you'll notice that these points are really close to the line. So if I had to estimate a correlation coefficient, I would estimate close to +1 because it's got a slope that's positive and it's going up. So this one I might guess to be about 0.97, 0.98. This one in general is coming down, right? It's got this downward vibe, sort of, but the stuff's all over the place. So I might want to call this like -0.3. Remember, the closer it is to 1 or -1, the better correlation coefficient. You have a good positive correlation, you have a good negative. The more I exercise, the longer I live. The more I smoke, the shorter I live. Some positive, negative correlation. But if it's spread out like this could be, we could almost say this is just no correlation, 0. This one has a negative correlation. But when I draw that line of best fit in, they're all over the place. So I might want to make this like -0.6. Maybe -0.7. This one's got a really tight negative correlation. We'll be like negative point, I don't know, it's like the other one, -0.98. Let's go. And then this one's like really good. This one's probably like 0.99. Notice it's positive this time because it's going upward direction. All right. The table on the right shows the number of stores in a coffee shop chain that opened during the years 1986 to 1994, using x equal to 1. And oftentimes they do this. Be careful. We're not putting these numbers in. 1986 is 1. That makes this 2. That makes this 3, 4, 5, 6, 7, 8, and 9. 6, 7, 8, 9, 10, 1, 2, 3, 4. Okay. So, and y represent the number of new stores. Round out, so we want to do some exponential regression on this data. It's going to tell us exponential regression. So we got to get these in our calculator. Oops, wrong one. So I go to my calculator, I go into this mode. I'm going to call one of them, I'm going to call this line year, and I'll call this one stores. And this one's easy. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 stores, or 9 years. And 14, 27, 48, 80, 110, 153, 261, 403, and 681. Boom. Go back over here, put my thing up here. There we go. So I'm going to go into menu, statistics, stat calculations, and they told me I had to do exponential regression. Now, in order to do regression, you have to give it 2 lists. You have to be able to compare one thing with one thing. And this time, we're comparing years to number of stores. So my first one is years. Don't just click on the first one. Years is going to be my x-axis, and the number of stores will be my y-axis. I probably shouldn't have used y for years, even though it's the x list. But y stands for years. I should have probably typed in year, make it look more obvious. So there's the equation. 2 common mistakes made with regression. The first one is, very simply, not typing in the data correctly. You put in a 46 instead of a 48 or something to that effect. Or in this case, you use 1986 and 1987, 1988, and you didn't use 1, 2, 3, 4, 5. Common mistake made. The second one is not Well, let's get down what a and b are equal. Well, the equation is this. Y equals a times b to the x. Now, if you forget that, it's okay. They tell you right here what it is. But notice they don't tell you the y equals. If you fail to put the y equals and they ask for a regression equation, which they always do, and you don't put this y equals, you lose a point. On a 4-point question, you're down to a 75% just because you forgot a y equals. It's kind of harsh, but that's the way it is. You also need to explain exactly what your a value is. Now, if you can't read it all, just highlight it, and down here it'll show 10.59599, 10.59599. It's not good enough not to just put it all down there. 22955, 22955, 13. I didn't leave much room here. So B is equal to 1.5862. 1.5862. 01234. That's good enough. 01234. So now I'm going to write my equation. Y equals now the highlight what they want. Oh my gosh, I didn't tell you what to round to. All right, so we are going to round. I'm going to add this to the end here. They always tell you what to round because this is where they love to take off points. Oh, here. I split this up. That should have been up there. So round to the nearest thousandth. So thousands is 3 decimals. So I'm going to put a line here at 3 decimals, and I'm going to put a line here at 3 decimals. So the equation is A. So 10.596, and I like to put B in parentheses. 1.586, 1.586 to the x. So there's my equation. Notice it's got a y equals. It's rounded properly. There it is. Use this estimate to find how many scores open in 2000. So I got to get to 2000. So 95, 96, 97, 98, 99, 2000. 10, 11, 12, 13, 14, 15. I want to find the year 15. It's 15 years. So I'm going to write this equation. I'm going to basically, all I got to do is y equals, and you need to put this in here. If you don't show this work, you lose credit for not explaining what it is you're doing. So 586 to the 15. This is part of your work, explaining where you got the 15 from, putting it in with 15. You're going to write your answer without rounding. So you're going to put 10.596 parenthesis. Use the rounded equation, 1.586 parenthesis raised to the 15th power. So you get 10,707, 10,707.5397, 5397. Now we're going to decide where to round to. Round to the nearest 5 stores. Wow, that's freaking weird. But that's how they do. You got to be able to say, okay, how accurate do I want this data? And that's just the way it's got to be. So 5 stores. This is 10,707.5. So that's a little bit over 7.5, right? So if I want to round this to the nearest 10 stores, wow, or 5 stores, this one's going to be 710. Wait. Yeah, because it's closer to 10 than it is to 5, because this is over, right? Because my cutoff then would be, wow, that's really crazy. So 5, halfway between 5 and 10, which would be the next 5, would be 7.5. That would be the cutoff. Anything before 7.5, I go there. Anything after 7.5, I go there. So there's the answer. All right, I'll be back. I just noticed I haven't even had any of my coffee. I was talking about having my coffee, but I didn't have any of my coffee yet. So let's get ready to roll while I drink a little bit of coffee. It's still really hot. So the accompanying table shows the wind speed of the corresponding wind-chill factor. The air temperature is 10 degrees Fahrenheit. Write a logarithmic regression equation. Ooh, man, that sounds tough. for this set of data. Rounding coefficients to the nearest 10,000ths place. Now, 10,000ths place. I'm going to highlight that sucker. 10,000ths place. Just so you know, that's 4 decimals. And then we want to find out when it's 40 miles per hour. Okay, so first things first, we got to get this data in our calculator. So we'll go to our calculator. I got other crap in there. Let's get rid of it. Go back in. See, we're going to call one X, and we'll call this one Y. All right. 4, 5, 12. 4, 5, 12, 16, 22, 31. Boom, 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 boom. 3, 1, 3, 1, negative. Oops. A negative 5 is going to be hard to put in. I got to put that in over here. Negative 5. Negative 7. If you use the keypad, I think it's going to be a little bit messed up. Negative 10. And negative 12. I think I got those all in there, right? Most common mistake is not putting the numbers in correctly. Check them. 22, negative 10. 16, negative 7. 12, negative 5. 5, negative 1. And 4, 3. We'll come over here. We're going to go into menu. Stats. Stat calculations. Logarithmic review. I haven't done one of those in a while. Logarithmic regression. I'm going to assume we're using this one. I haven't done this in a while, actually. X, Y, click OK. Domain area. So menu, statistics, stat calculations, X, Y. There it is. That doesn't look right. Oh, this is the one I want. Jesus. I'm like, I told you I haven't done this in a while, and I knew it wasn't that hard. I didn't remember these D's. This is the one I want. Oh my God, that's so embarrassing. I just want X and Y. Oh my gosh. Oh, that's so embarrassing. I'm like, what is that? Oh, yes, that's okay. Okay, there we go. Looks like we're using natural logs for some reason. All right, so A plus the natural, a B to the natural log. Okay, so, woo. All right, that's better. So we need A and B. So it's Y equals something's. Yeah, we're right. We're good. All right. Escape. All right. So A equals 13.0134. Also, the equation, I forgot to write the equation. A plus B times the natural log of just X. All right. So got to write down what A and B are. Oops. A and B. So let's get that down. 13.0, 13.01, 3429, 3429, 3437, 3437. Man, don't write these down wrong. Negative 7, negative 7.31348, 31348. 58761, 58761. All right, so we end up writing our equation. Y equals, we want to round to the 10,000ths place. Let me highlight that. 1, 2, 3, 4. That's this one. 1, 2, 3, 4. That's this one. So Y equals 13.0134. Why do my 4s always look like 9s? 4. Let's do an exponential. Plus, in this case, it's minus 7.3135 times the natural log of X. Woo! Now I want to do 40, so I'm just going to do y equals 13.0134 minus 7.3135 times the natural log of 40. Not 90, 40. Gosh. Now, if I had to estimate, I'm looking at 40, probably going to be somewhere around, let's see, that's another 9. That went 10, it only went 2, so another 10. I'm going to guess maybe now negative 14, maybe. So we'll go to our calculator, we'll type in 13.0134 minus 7.3135 times the natural log of 40. Enter. Oh, I have 73,000. Maybe that's why that's not going to work. I'm like, well, that doesn't make any doggone sense. I forgot the decimal. And it looks like I have a times here. And all kinds of issues here. 13 point. Oh, there we go. Negative 13.844. That makes more sense. Don't just be a monkey and write down what they tell you. Negative 13.844619. And they want it rounded to the nearest tenth of a degree. So y equals negative 13.8. Woo! All right, I'll be back. That was painful. Got messed up all kinds of stuff. Okay, so the points in the scatter reading's not very good for me today. Below represent the age of automobiles and their values. Based on the scatter plot, it'd be reasonable to conclude. So as these cars get older, their value is going down, right? So that's got a negative correlation, and it's relatively strong correlation. Age and value have a coefficient of correlation that is less than 0. Wow, that looks pretty good because it's coming down and it's got a correlation coefficient that's negative. That sounds pretty good. Age and value have a correlation coefficient that's equal to 0. If the correlation coefficient is equal to 0, that means they have no bearing on each other. There's no way to correlate age with value of car. That doesn't make any sense whatsoever. Age and value have a correlation coefficient that's between 0 and 0.5. That means there's very little correlation, and it's positive. That means as the car gets older, you might expect it to gain in price. No, that doesn't make any sense. Age and value have a correlation coefficient that's greater than 0.5. This one's saying definitely as the car gets older. This one was maybe because it was only between 0 and 5. This one says bigger than 5. It's definitely going to happen that as your car gets older, it's going to gain in value. No, that's not true. The answer is definitely A. All right. The number of newly reported crimes in a county in New York State are shown in this table below. Write a linear, that's an easy one, linear regression equation that represents this data. We got to be careful here. Let x represent 1999. So this is 0, x equals 0. This is 1, this is 2, and this is going to be 3. So we'll go back over to our, I got to find my calculator. There we go. We'll get rid of this. Don't need this. Get rid of this. Get rid of this. Don't save. And go back into this. And we're going to call this X. We're going to call this Y. And we got 0, 1, 2, 3, 4, 4, 0, 4, 5, 7, 3, 6, 9, 3, 5, 1. That's weird. All right. Well, it seemed to have gone up and then went down. That's weird. So we're going to do linear correlation. So we're going to menu, stats, stat calculations, and we're going to do mx plus b, right? We don't do a, whatever that is. Who knows what that is? Nobody knows what that is. We'll call this x, call this y, and we'll click OK. So hopefully they only don't tell us. God bless it. Why do we keep going back to this? All right. So write a linear, so we're going to write down, they didn't tell us what around, so our linear correlation is mx plus b. So we got to write down what M is. M is negative 35.5. And B is 457.5. 457.5. So our linear regression equation is negative 35.5x plus 457.5. It said project the number of cases for 2009. 3, 4, 5, 6, 7, 8, 9. Now you could just realize it's one more than what's already there. 4, 5, 6, 7, 8, 9, and this would be 10. So we're going to plug in x equals 10. So y is equal to negative 35.5 times 10 plus 457.5. And then I'm going to talk to you about negative or positive correlation. Since it has a negative slope, my correlation coefficient probably is going to be negative. But this data seems to be kind of all over the place, so it may not be a very good correlation coefficient. So let me get into my calculator. So negative 35.5 parentheses 10 parentheses plus 457.5. Enter. So 102.5. 102.5, round to the nearest whole number, so y equals 103. That's the answer to this question. But let's take a look at the correlation coefficient. Oh, crap. See if it's going to allow me to go back to it. There it is. So there it is right there. Oh, that's actually not bad. Negative 0.879. It's not great. It's not highly correlated. Highly correlated would probably be 0.97, 0.98, something like that. So this has got a good, strong, decent negative correlation, but it's not huge. But cancel. So, but it is negative 0.87. Okay, just as I suspected, it would be negative. All right, I'll be back. Well, we'll do one more. Maybe we'll do two more. The relationship between T, a student's test score, and D, the student's success in college, is modeled by this equation. The key here is this right here. Positive slope. The only thing that tells us is it has a positive correlation. It doesn't tell us how strong it is. It just tells us it has a positive correlation. So our correlation coefficient has to be between 0 and 1. It can't be equal to negative 1 because it's positive. It can't be equal to 0 because it does have a slope. So if it was 0, it would be all over the place. But the reason you can't tell it is this has really a positive slope of a half. So if I was to look at this equation, it might look like data might look like this. So it's got a slope of a half, and if I draw in that line of best fit, it's going to look like that. Well, that's a slope of y equals 0.48x, and then it says plus 75.2. But it doesn't mean it can't look like this. So originally I drew one that might have a correlation coefficient of like 0.8, 0.9, 0.95. But this one is probably closer to like 0.75 maybe. So who knows how big and who knows how strong it is. I just know it's positive. Which value represents data with very weak linear correlation between the two variables? Very weak means closest to 0. And this would be closest to 0. This can't even happen. So if they ask for the strongest linear correlation, strong linear correlation, you want the one that's closest to 1 or negative 1. Well, this is actually the one that's closest to 1 or negative 1, but it can't be bigger than 1. 1 is like perfect. Negative 1 is like perfect. Anything more than that can't happen. And then so the answer for strong positive would be this. The answer for strong negative would be this. And then no correlation would be that. All right, I'll be back. Can you hear me now? Okay, I just checked my audio. I forgot to check my audio before I got on. Okay, I think we're good. All right, I'm back. It's like 10 hours later than I was before. Holy crap, blessed be. Okay, so I don't even remember what we were talking about. Here we go. We're going to talk about regression, though. I'm pretty sure that's what we're going to talk about. So, regression. Concentration in milligrams of medication to patient's blood, blah, 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 blah. We got to get this table put in. So let's get this table put in. let's do this. Let's move this over. Can I move this over as much as possible? That's it? That's not going to be helpful. Why can't I go over? Maybe put it down. I don't know. Bring the calculator up. Not going to be useful. So I guess we're going back and forth. All right. So we've got time and concentration. Time is the x value. Concentration is the y value. And it's going up by 0.5. So 0, 0, enter, 0.5, enter, 1, enter, 1.5, enter, 2, enter, 2.5. I think that was the highest one. And then we go 0, 78.1, 0, 78.1, 99.8, oops, 99.8, 1.5, 88.8, 84.4, 2 is 50.1, and 15.6. See? It's so easy to put the wrong number in. I think it was 15.6, wasn't it? I hope I got those in right. You let me know if I didn't. How you can do that? This is pre-recorded video. All right, so we got these in. So we'll go over here. We'll go to menu, statistics, stat calculations, quadratic. So stat calculations, and we're going to do a quadratic regression. Boy, we haven't done a quadratic regression in a while. Time is the x value, concentration is the y value. Click OK. All right, so if you know notice with a quadratic, there's the equation right there. So our quadratic equation is y equals ax squared plus bx plus c. So now I got to give you what a equals, what b equals, what c equals, and then the equation. And don't forget, your equation has to have a y equals. Failure to put a y equals is such a stupid point to lose on the Regents exam. Stupid. Stupido. I think that means stupid. A is negative 56.214. That seems weird. Negative 56.214. 285. Good enough. B is 139.312. 139.312. 857. And C is 9.35. Weird. And it says round this. Find the equation. Round to the nearest thousands place. Well, that's interesting. I feel like I didn't do this right. I feel like I put the wrong numbers in. Let me make sure I got the right numbers. 0, 0, 0.5, 78.1, 1, 99.8, 1.5, 84.4, 2, 50.1, and 2.5, 15.6. Okay, whatever. So if I want to write the equation is going to be y equals negative 56.214 x squared plus 139.313x plus 9.35. Now, this is rounded near thousands, but this only gave us hundreds, and you really can't put that thousands in there. I guess you could put a 0 in there. How many hours to the nearest hundredth of an hour after the medication is administered will it reach its highest concentration in the blood? So we're looking for a maximum. And a maximum is found at x equals negative b over 2a. That's where we found our maximum. So we're going to do negative b, which is negative 139.313 all over 2 times negative 56.214. So that's the x value. It says after how many hours. So we're going to figure out what this is. So x equals, and we're going to round it to the nearest hundredth of an hour. So we're going to do negative 139.313. It's negative b over 2a. 2 times negative 56.214. Enter. And I get 1.239. 1.239130. Rounded nearest hundredth of an hour, so our answer is x equals 1.24 hours. What will the concentration be at that point. So what we're going to do is we're going to take this and we're going to plug it into this equation. So we're going to do f of, really, actually we're just going to plug in this in for x. So y equals negative 56.1214. We'll make silly mistakes. 214, 1.24 squared plus 139.313 times 1.24 plus 9.35. So 1.24 stow x. I'm just going to do it like this. And then we're going to do negative 56.214 x squared plus 139.313 x plus 9.35. 95.623. So y equals 95.623. 496. Round to the nearest hundredth. Y equals 95.62. Now see if that makes sense. 1.24 would be somewhere in here, and it would be maximum. Notice it's not as high as it was at one point, but remember this is all based on a approximation, so it's not exactly the most accurate or exact. What the heck? After how many hours to the nearest hundredth of an hour after the medication is administered will it be out of its place, out of the bloodstream? That means y equals 0. When will it equal 0? So we have to do the quadratic formula on this. There's no way to do this any other way. So we're going to do a equals, we already know what a equals. What we're going to do it, negative 56.214. B equals 139.313, and C equals 9.35. And D is equal to B squared minus 4AC. So, parentheses, negative 56.24 parentheses squared minus 4 times 139.313. That's, it's B squared. What am I doing? So it's B squared, so it's parentheses 139.313 squared minus 4 times parentheses negative 56.24 parentheses times parentheses 9.35. There it is. 21,511. 21,511. You really should show those 487.969. So you really should show what you substituted in here. So x equals negative b over 2a. So that would be 56.214 over 2. My goodness, I'm having a hard time with negative b. Negative b, so it would be negative 139.313 all over 2 times negative 56.214 plus or minus the square root of 21511.487969 all over 2 times negative 56.214. Man, in retrospect, I should have stowed all those numbers. So x equals, control division, negative b, negative 139.313. I think I must accidentally hit the minus button. Negative, all over 2 parentheses, negative 56.214 parentheses plus control division, the square root of this all over 2 times negative 56.214. Enter. That doesn't make any sense. What happens when I do a minus here? Ah, 2.54. So x equals 2.54368. So the answer is 2.54 hours. It'll be completely out of the system. Let's see if that kind of makes sense with our graph. Yeah, somewhere a little bit after this, it'll be completely out of the system. 2.54. We got just a little bit. Okay, that's about right. Whew, that was a tough one. All right, I'm going to pause it. I'll be right back. Man, oh man, I wish I had a cup of coffee. Anyway, we're on the last problem. There it is, last problem, number 8. This one's going to be an exponential regression. So let's get those numbers in. They're going, looks like it's going even, 0, 2, 4, 6, 8, 10, 12. We just don't have 14 in there. That's just by design to see if you're paying attention. You know, we like to mess with you kids. X and Y, let's just call them X and Y. It really doesn't matter. So 0, 2, 4, 6, 8, 10, 12. No 14. We'll go right to 16. Kind of annoying. I hate when it does that. All right. 25, 36. 25, 36. 52, 68. 52, 68. 85, 104, 142, and 260. Boom, done. Remember, most common mistake made, not entering the data right. I would do these problems twice, bros and sisters, whatever. Everybody, do them twice. Do them twice. My kids, your kids, everybody should do these problems twice. So we're going to go to menu, statistics, stat calculations, exponential regression. We have an X list, X. We got a Y list, Y. And we click OK. Gives you the equation. There it is right there. It is not got the y in it. So you need to write y equals a times b to the x. You need to tell the grader exactly what a is. 27. Again, highlight it like this and you'll see it down here. 27.202, 27.202, 511. 6 decimals is enough. And then b is 1.1508, 1.1508, 733. So round all values to the 10,000s place. 1, 2, 3, 4. There's the 10,000s place. That's the most I've ever seen. 1, 2, 3, 4. It's a 4th decimal place. So we'll round them all out there, and we get y equals 27.2025 parentheses 1.1509 to the x power. And finally, it says, using these equations, predict the number of single-cell organisms to nearest at the end of the 18th hour. Okay, we just got to plug 18 in. That's it. Man, we're almost done. Y equals 27.2025 1.1509 raised to the 18th. So go over to our calculator. Boom, boom, boom. All right, so we're going to do 27.2025. Of course, I forgot the decimal. 27.2025 parentheses 1.1509 parentheses raised to the 18th power. Write it down exactly. 341. 417. 2, 3, 4. Now we round to the nearest whole number. Y equals 341. There it is, kids. That's the end of this lecture on regression. It was so much fun. Have fun. Goodbye.